Okay, now I'm beginning to feel really dumb because I was wondering why those density measurements came out the same. Because we are supposed to figure out the buoyancy force. I was chasing my tail. I knew I was doing it. I calculated the buoyancy force wrong. That's why we measured the brass above the water and in the water. Excuse me. We even went over it in class, but I spaced when I did the spreadsheet. Excuse me. So we have these in the spreadsheet, and remember that, and I did this discussion back here. It's pretty funny. I'm spending all this time a little while ago showing you this, and it's like, I mean, look at that. It's right in front of me. Why in the world did I not use this? Oh well, boy, I'm tired. I don't know if I'm going to finish everything tonight, guys. But let's go back to the spreadsheet then. And I'll put this up. Oh, you can't see this up where you can't see it, but so I can see it. So spreadsheet, where are you? Where the hell did you go? Here it is. So let's zoom in on the buoyancy measurement. Well, another thing we need though is we need this guy. So we have mass. So what we're gonna do is we're going to, oops, not like that, like this. We're going to insert these two columns here. Boy, I feel dumb. Shift everything right. Then we are going to copy and paste these guys in here. And values only, why not? Let's try that out. Something's not right. I see it. Oh, what happened there? Why did that happen? Okay. Mass apparent. Well, this is, oh wait, I see. That's not what I want there anyway. I want the mass apparent. Copy. Let's try again. Okay, let's make these a little bigger. I thought I had this set to wrap. There we go. And so we'll just set this one to wrap too, just make our lives a little easier. And then I need to cut, paste, and these are also both in grams. For sure this could be done better. Okay. So this is all stuff for part 2. Let's finish part 1. So will it all fit there? Yep. So I said we just have to take those two quantities. If I divide by G, so let's think about this. What we actually have are these two numbers. So if we have just MB minus M apparent, this is going to equal it's the mass of the, it's funny, that's in principle going to equal the mass of the water, huh? Yeah, of course it is. Well, these are we got to think of them more as forces. This is what sucks about balances measuring for newtons, right? So if we multiply the difference by, then that'll get us FB. Okay, good. Okay. So this is actually going to equal this minus that, but I also forgot I need some parentheses, and that's in grams. So I have to, first of all, let's put the other parentheses. I got to divide that by 1,000. And then I multiply it by 9.8. And then I'll get the F buoyancy in Newton. So I don't know. It looks, yeah, it is different because now that row is different. Oh, gosh. And now, though, we have to be a little careful, because now we have to do a different error propagation. Remember, it's down here. So the plus minus of F buoy is going to be the plus, and it's subtraction. So this A is equal to M apparent. No, mass, the actual mass minus M apparent. And so, and then we multiply by G, but that has no error, so we don't care. So we don't, little a and little b are both 1. So we got to take the sigma, the plus minus squared of 1, plus this plus minus of the other one, plus minus squared of the other one, and then see it's, we have to square root it, of course, but there's no scaling by f of b. Interesting. So that means, pause time. Okay. So I have to remember that we scale things by 1,000 to convert to kilograms. So we still going to do the plus, what's going on here? Plus minus, M brass squared, and if we would divide that by 1,000, divide that by 1,000, and then that would be squared. Now let's just do it out first. Maybe we can see the common terms. Plus minus MB divided by 1,000, because it's in grams and 1 in kilograms, squared, and plus minus M apparent over 1,000. Something's in my way here. And where'd it go? Okay. We don't need figure of merits. And by 1,000 once again, squared. And then we have to square root it. So I can, yeah, I see the common term. So it turns out that it's going to be plus minus FB is just going to be 1 over 1,000 square, but we can pull it out of the square root. So it's simply 1 over 1,000 times plus minus M brass squared plus M apparent squared plus minus M apparent squared. Yep, and then that gets square rooted. Okay. It's not easy, right? And it's a lot of careful bookkeeping. So let's go for it. Equals SQRT of plus minus the mass of the brass squared plus minus the mass, yeah, I said that, plus minus the mass apparent squared, and then divide that by 1,000. Wow, so it got to be a lot smaller, which is interesting because the difference between these things is pretty, oh, what did I do wrong now? Oh boy, I did it in the wrong box, huh? One more time. This is, first of all, got to be cleared out. The buoyancy is 0.421 newtons, slightly different than before. Okay, equals square root of the plus minus mass brass squared plus the plus minus of the mass apparent squared, and then we have to divide by 1,000. And do I want to accept? Yes, I forgot the multiplier. Isn't that interesting? Oh, divided by, not times. I was going to say, I'd expected it to grow, but not. And in fact, it's off the charts here. Let's see. It's quite small. Interesting. But the plus minus rho became less smaller too, and that's too bad because that's meaning that, well, I have to double check it, but for you guys it's fine. It's not so much that you get it right, but that you see how tedious this is, but it's very important. In the real world, we wouldn't be under the gun so much, so we could have other people look at it and check for us and that kind of thing. Okay. So that's the correction.